right, so we are now recording, so I will post my screen. And hopefully you guys see my my notebook screen. Hopefully that'll come up on your screen in a second here. And you will see that we are going to take up the homework assignment. Do you guys see that now on your screen?
Yeah.
Yeah, perfect.
Yeah.
Somebody sees it. I know the rest has. So let's just go through this. You guys submitted it. I went through. Unfortunately, I'm not able to mark them up and give them back to you, but I did see some very common errors that occurred over and over. So if you have your assignment out that you submitted to me, that 6-page assignment, I'll show you a couple things that if there were errors, this is where they possibly would be. So have that out in front of you, and I went and I cut and paste just some pages from different peoples that did well on the assignment. So here's the very first page. The first question, you're babysitting getting $7 an hour, okay? So you start at 0 hours, and please note that you don't get paid anything if you don't babysit at all. This is a direct variation. That's why it's under direct, but every time you go up an hour, you go up $7. When you graph this thing, it should start down at the bottom, go up to the right, and it was nice here, you're going up by 3s. When you're going up by 7s, sometimes what I would do is go every 2, up by 7, up by 7, and then you know you're right on a line every time. It's something you can do, but I like how this person went up by 3s, and they were just very accurate with their plotting. Identify the constant of variation. That's 7. It means every time you babysit another hour, you get paid $7. Constant of variation. And what's the equation? Y equals mx. So y equals 7h. The only thing that I may have done different here, if I were to do this question, is maybe use the variables that are in the question. Do you see how it's earnings and hours? So instead of y, maybe what you would do, let me just switch my pen so I don't have any erase. But maybe you do earnings equals 7, and then time, usually we use T for time instead of H for hours, but I completely understand what this equation means. Y equals 7H. This may be an ideal one, a little more for earnings and for time. Now, I don't know if this was something that a teacher taught in grade 8, so there was a whole cluster of you guys doing this, but a lot of people were putting the variable before the number. This is not going to fly the rest of high school, okay? We want the variable after the number. Coefficient, then the variable. So some of you have an assignment, you would have E equals T times 7 or T7. Put the 7 first. Coefficient, variable. All right. Over here, partial variation. Notice this is partial because of this right here. It's 0 and 100, not 0 and 0 right here. So when you have 0, 0 up front, direct. 0, some other number, partial. So what's the initial amount? Well, it is savings and time in months. As soon as this person opened up a bank account, they put $100 in. That's their initial amount. When time was equal to 0, I'm opening up a bank account and in goes $100. Then every single 2 months, up by 2, up by 2, up by 2, up by 2, we're putting in 500, 500, 500, 500. But 500 is not our rate of change. It's what is our rate of change per month, per hour, per year, per minute, always out of 1. So if you're going up by 2 for your months and you're going up by 500, then you go 500 divided by 2, that's where you get the 250. And again, in this question, this is correct. There's nothing wrong with this person's answer, but do you see what they give you here in terms of your variables, S and M? I think I would have just done here, savings equals 250 with an M, because they told you months, plus 100. I would switch the Y and the X to S and M, okay? You can graph the thing. Notice we started off the origin right here. I know it's close, but you can see it's off the origin, partial. And that is the second question. Everybody good there? Third question. 8 cents for every brochure plus $1,500 up front. There's a one-time cost of setting everything up, the printer, the program, all the pictures, all the font, $1,500. And once we get that done, every time we print a brochure, it's 8 cents. Fixed amount, $1,500. Variable amount, 8 cents per program or per brochure. So instead of Y equals, maybe we go the cost equals. And that C is going to turn into a spotlight. But maybe we go cost equals 0.08, and I'll put N for number of brochures. Y and X will work. That's correct. It's just not as precise. So cost and N for number of brochures, or B for brochures. What's the total cost of 800? Multiply 800 by 0.08 and then add 1,500. You get your final answer. It's very cheap to print off brochures after you get the setup of $1,500. Is everybody good with the first page? All set? Second page. This is from somebody's. They did a pretty good job here. Sorry. I'm going to go back here. I'm going to clear the ink, and then I'm going to cut this away. Here's your second page. So this person here found slopes. Now, before you even do any rise or run, take a look at this line, AB. It goes down to the right. It's got to be negative. This line goes up to the right. It's got to be positive. Okay? So we go down 2 over 5, negative 2 over 5. For whatever reason here, people were putting 1 over 5 instead of 5 over 1. Our run is 1. Run is on the bottom. Rise is 5. So 5 over 1 is 5. Before I even look at these slopes, positive, negative, positive. Positive, up to the right, negative, down to the right, positive, up to the right. There should be no reason you mix up positives and negatives. So the first one, positive, up to the right, up 5 over 6. Rise over run. Down 3 over 7. Negative 3 over 7. That's the negative one. Up 3 over 7. 10. Up 3 over 10, so 3 over 10. This person here, negative 3, back 1, 2, 3, and negative 4, down 1, 2, 3, 4, and they put a point A right there. Their slope is 7 over 6. Rise, 1, 2, 3, 4, 5, 6. Run, 1, 2, 3, 4, 5, 6, 7. We ended up right here. What are the coordinates? 4 and up 2. The coordinates of B are 4 and 2. All right, is everybody good with that part? All right, let's go to the next one. I'm going to cut this away. Here's the next one. A rental car, $50 up front per day plus 20 cents a kilometer. So what's the dependent variable? It's cost. The cost depends on the number of kilometers. Now, when we fill out the table, we're going up by 200, so 600, 800, 1,000. How do we come up with this number? It's 50 plus decimal 2 times the number of kilometers. So you rent a car, they drop it off in your driveway, and they pick it up at the end of the day, and you haven't even driven it. 0 kilometers. It still costs you $50.
Mr. Bracken.
Yep.
On your screen, it's for. Oh, never mind. No.
Is it okay now? I just saw it switch over on my other one. I'll keep an eye on my other computer, and as soon as it switches over, I'll start, okay? Sorry about that. Real quick, dependent variable is cost. Up by 200s. And even if you don't drive the car, it's still $50 up front. But now we get the 90 by going decimal 2 times 200, which is 40, plus the 50 is 90. Decimal 2 times 400 is 80, plus the 50 is 130. Decimal 2 times 600 plus 50, decimal 2 times 800 plus 50, 1,000 times decimal 2 plus 50, you get your table. This is partial variation. We graph the thing. Make sure you do your scales on the side. We graph it. We come up with the equation. See right here, the n is in front of the decimal 20. I would just write it decimal. Let me get my pen here. And I'm going to make my zeros look a little bit funny here, just so I don't get that spotlight. But 0.20, and then put the n after. Okay, switch the n to after. This is correct, it's just not precise. Put this n after. It is partial because there's an upfront cost of 50. When you plug in 45, 45 times decimal 2 plus the 50 gives you 59. First one done. Okay? Cut this away. Next one. 500 in Holly's bank account. She takes out 50 each month. Number of months, 0 all the way up to 6. It says right here. We start with 500. Down 50, down 50, down 50, down 50, down 50, down 50. She keeps spending $50 a month without putting anything back in. We graph the thing. Here we went up by ones. Here we went up by hundreds. Be careful here. I'll just notice this. Do you see here how you made one line a jump of 100? And then you made 2 lines jumps of 100? Just skip a line right here. This 100 should be up here and then go every other line. Don't skip between 100 and 200 and then not skip between 0 and 100. Okay, so just make sure you skip a line here too. The equation, your balance, I love that. Balance, B, is 500 up front, take away 50 times the number of months. What a great equation. Okay, this is partial because the line does not go through the origin. This is partial because it's 0 and 500 in the table. This is partial because when she opens up the bank account, she puts 500 in immediately. And this is partial because the equation is y equals mx plus b. If you went minus 50n plus 500, it looks like y equals mx plus b. Okay. How much will she have in her bank account after 8 months? Bunch of ways you can do this. You can kind of estimate here. You can go to your table, your equation, but she will have 100 left. And when will she have 50? 1 more month. So after, not after 7, this should be 9. After 9 months, she'll have 50 left in her account. Okay? Everybody's good with that one? All right, I'll cut this away. I'll wait for the new page to come up. I think it's up in the screen now. I can see it in my other computer. So Nisha is learning to snowboard. White Mountain charges $10 an hour for lessons and $40 for the lift ticket. This makes sense to me. If anybody's ever been skiing, before you can take a lesson from somebody at the ski resort, you've got to buy your ticket to get into the ski resort. You've got to buy your lift ticket. Then you can start taking lessons inside. So this makes sense. Make a table of values for up to 6 hours. 40 up front. Every time we take a lesson, $10 more on top. Graph. Equation is awesome. I love the T and the C. Okay, and here, partial, 2.5 hours would cost $65. Plug it into your equation. And then also, Nisha paid $75. How long would it take? This person did a trial and error, which is fine. What you could do, though, is you could take, and just like we did in chapter 4, you could say, okay, cost is 75. This equals, cost is 75, 10t plus 40. Now, how would you solve this equation? You would bring the 40 to the other side, take it away from 75, and then divide by 10, and you would still get 3.5. This was trial and error. This is how you could set up your equation to solve, okay? I mean, what if you said it cost you, you took lessons all day and it cost you $525? You don't want to keep trial and erroring here. Just put 525 and solve the equation, okay? But very well done, this one here. Last one, commission, okay? Commission, 20% commission. If you screwed up a table, this was the one. Here's what commission is. Real quickly, I do not get paid on commission. I get a salary. It doesn't matter how good of a teacher I am or how bad. It doesn't matter whether I teach 20 students or 2. I get paid the same amount. But my best friend is a used car salesman. He gets paid on commission. The more he sells, the more he makes. So what you do with percent, this percent means out of 100. 20% is 20 out of 100. And when we divide, we get 0.20. Every time you sell $1 worth of stuff, you get 20 cents. So you're taking this number, and to get the next one, you're multiplying by decimal 2. You sell something worth $10,000, the store is going to pay you $2,000. Don't multiply by 20, because if you got 20,000 here, this store would not last too long if you sold something worth 10,000 and you got paid $20,000. That doesn't make much sense. Okay, even this commission is high, but that's what commission is. The more you sell, the more you make. You don't sell anything, you don't get paid. Direct variation. So sales on the bottom. Okay, I didn't notice this, but sales should be on the bottom. commission should be on the side. So the person that did this, just make sure you make that correction. The scales will flip-flop, the graph will be the same. Equation, I really like this. That's why I like this one. Decimal 20 times n. Say, commission, I would use C for commission equals 0.2 times n, the number of sales. This is direct. You can plug in 8,000 and solve, okay? And you can always do your equation the same way as before. So 975 is equal to 0.20 n, and then we don't need the rest. And you can just solve this equation, divide by decimal 2, and you get almost $5,000. Okay? Any problems there? That makes sense to me, because if you're going to get paid $975 and it's almost $5,000 what you sold, you see how that 5,000 is almost between here, and that 975 is between here? Makes sense to me. That is your assignment, okay? So this is being recorded. If you wanted to go through it again, you can. Your homework, though, on first differences, I'll give you a second just to take a look at your homework from last night. I'm not going to completely take it up, but I'm going to touch on a couple of things because after today's lesson, some of the problems I think you'll be able to solve. Okay, so I'll give you a second, find your homework from last night. You had those handouts to finish and then a couple textbook questions. In the meantime, if you haven't already done so, please take the attendance under the chat section there. Click on the form and just say whether you're cohort A or B. All right, so just looking at this real quick, it says complete the table and do the first differences to see whether it's linear or not. Then write an equation. Just let me highlight a couple things here. All right, so do the first differences to see whether it's linear or nonlinear. That's the first thing. The second thing is write an equation. After today, you will be able to do this yellow. I'm not going to do the equation here, but after today, you will be able to. And then extrapolate to predict the outcome for the seventh step, the seventh number, okay? So for the very first one, this is the number of circles and the number of intersecting points. Well, with one circle, there's no intersecting points, but with two circles, do you see the intersecting point there and there? There's two of them. For three circles, 1, 2, 3, and 4. And every time you add a circle, you're adding 2 more intersecting points. So we're going up by 2. So when you do your first differences here, you should get first differences always of 2 here. And since they're all 2, this is linear. You will be able to do the equation at the end of today's lesson. If we went to the seventh step, 5 would be 8, 6 would be 10, 7 would be 12. I believe we're going to get 12 intersecting points. All right. Next one, diagonals. Just so you understand what diagonals are here. Diagonals are the lines going through the middle of a. So the first one we can count 2, and the next one we can count 5 pretty easy. But when we go to this next one, the number of diagonals, I will just do for you here. Come on. The number of diagonals you can create, and I will just use red here. So if I start here, I get not this one, but 1, 2, and 3. I go to the next one, 4, 5, and 6. Now this is already done, so 7 and 8, this one's already done, and 9. So that's how I came up with this for 9 right here, okay? When I go to the next one, you can create it, but for the first one, 2, then I go to 5, then I go to 9. And what you're going to see is you're going to see up by 3, up by 4, the next one's up by 5, then we go up by 6. You can keep this pattern going. This is the first step, the second, the third, the fourth, the fifth, the sixth, the seventh. Extrapolate to get to the 7th step. not the number 7, but the 7th step, which would be down here. Okay, so that would be 8, 9, and 10. You can see how many you would have. Follow the pattern. This is not linear. Okay, you'll be able to come up with the equation next year in grade 10. We do not find nonlinear equations in this course. Toothpicks. 4 in the first one. So diagram 1 is 4. Diagram 2 is 7, and diagram 3 is 10. Notice I left this first one. Whenever I make a table, it's not given to me, I always put 0 here. So even though we don't have a diagram 0, I can backtrack. Take away 3, and we take away 3, we get 1. So if there was a diagram 0, it would be 1. And one way to look at that is, do you see, in order to go from here back to here, do you see how we take off 1, 2, and these 2? To go from here to here, you take off 1, 2, and 3. We're left with the square. And if we were to go back 1, do the same thing. Take off 1, 2, 3, and diagram 0 just has that 1 toothpick waiting right there. So you build this by saying we start with 1, and then for the next diagram we go 1, 2, and 3. To build the next one, 1, 2, 3, 1, 2, 3, 1, 2, 3. Our initial value was 1, and we add 3 every time. Okay? You can use the rest here in order to solve. Okay? Is everybody good so far? Just a couple people want to pipe in. I know I'm going fast, but it's being recorded. Is everybody okay?
Yes.
Yep, perfect. Now I love this question, and even if you understand all the stuff we've done, I want you to pay attention here, because this will set you apart, okay? If you take a look at this question, class conducted an experiment to see how high a golf ball would bounce, okay? We did this in class. Provide 2 or more pieces of evidence to show this is linear or non-linear. Here's the first thing I did. I went through and I found the first differences. We're always going up by 50 here. And when I did my first differences, 82 take away 41, 125 take away 82, all the way through, I look at this and I say, hey, these numbers are not the same. This is not linear. But I would argue that it is. I would say this is linear. Do you see how these numbers are close? 41, 43, 41, 42, 46. I think what happened was the person recording in class, 2 students doing this experiment, didn't quite get all these numbers exactly right. It was hard to take that golf ball and get it exactly where it bounced back up to, but you got it close. Though these numbers are not exactly the same, they are really, really close to like a 43, 42, 41. Maybe this one, because you were reaching up so high, your eyes were on an angle and you read it as 254. Maybe it was just 250. This is human error here, is what it is. So I would argue that this is actually linear. And if you had a powered camera and you were able to take pictures as soon as it got to the highest point, you would find that it is very linear. You could graph the thing too. Yeah, this point isn't exactly on the line, and this one's a little bit above and so on, but you can see how close to linear it is. So you can argue, hey, Mr. Bracken said they've got to all be exactly the same or it's not linear. Or you could say, you know what, I'm using my judgment here, and because it's an experiment and because we didn't have a high-powered camera and so on, it doesn't prove that it's exactly linear, but I think it is if we have the technology to do that. Okay? All good? Last thing before I pause this and we take a quick break here. Last thing. These two, are these linear or not? Okay, so we go up by 5, up by 5, up by 5, up by 10, then up by 5. Who's ever got their mic on, if you could shut it off there. Going up by 5 except the 1, that's going up by 10. Okay, I think that's you, Zach. Hey, Zach, Lanu, can you shut off your mic? I think Zach left for a second. All right. Now, when we graph this thing, I would say the first difference, 5, 5, 5, 10, and 5. This is not linear. But when we graph this thing, do you notice what actually happens here? When we graph this thing, we go 0, 0, right here. We go 1 and 5, right there. We go 2 and 10. We go 3 and 15. Our next point is 5 and 25. Zach Lanu, shut off your microphone, please. The next one is 6 and 30. Okay? Now, it looks to me like this is completely linear. What the problem was is there's just a point missing. 4 for time and 20 for distance. We're just missing this point right here. So maybe the person just forgot to record it. They're doing an experiment, and after 3 hours, they fell asleep. They didn't get to record for 4, but they did record for 5 and for 6. So even though we're going up by 5 here, 5, 5, 5, 10, and 5, we're going up by 1, 1, 1, 2, and 1. So we take the differences. 5 divided by 1, 5 divided by 1, 5 divided by 1, 10 divided by 2, and 5 divided by 1, they all give you 5. Okay? This is, in fact, linear. Notice we're not going up by the same amount here. So when we find our first differences, and I'll write these ones in, 40 take away 10 is 30. Next one, 60 take away 40 is 20. The next one, 20 take away 60 is negative. 30 take away 20 is 10. And 50 take away 30 is 20. At first glance, this thing looks as non-linear as you can get. These numbers aren't even close, like the science experiment. But when we go to the other side, do you see here how we go up by 6? We go up by 4. We go down 2 take away 10. We go down by 8. 4 take away 2. And 8 take away 4. Now, I don't care what number you take, but everybody with their calculator, take one number on this side, whichever one, and divide it by the number exactly across from it. I don't care which one you take. Take any one you want, but take this number and divide it by the one across from it. I guarantee you, you will get 5. Okay, 5 is your answer. The reason these are out of order, and if we put these in order, if we redo this table, 0 and 10, right here. Now the next one in line is 2 and 20. The next one in line is 4 and 30. 6 and 40. 8 and 50. And then 10 and 60. Do you see how they are exactly linear? So this table was just kind of put out of order, but if you were to rearrange these and keep the numbers that go across from each other, but if we were to move 2 up next, 2 and then 20, and then we put 3 and 30, 4 and 40, and so on, you will get exactly linear. Okay, or going up by 2s. All right. So just be aware of that. That might be on your test on Tuesday, but I am done for taking up stuff. So I'm just going to stop this so I have that video, and then we're going to start over here. We're going to take a quick second. We'll start over and do our new lesson today. But is there any questions on any of this?